In this video, we are diving into section 6.2, where we will learn how to construct confidence interval for the population mean when the population standard deviation is sigma is unknown. This is super common in real scenario where we have to work with sample data, not population data. When sigma is unknown and either population is normally distributed to O, your sample is 30 or more, we use the t-distribution instead of the normal distribution. The shape is similar to the bell curve, much the tail are thicker, especially with the smaller samples. That's because we are working with more uncertainty. When sigma is unknown, and either the population is normally distributed or your sample size is 30 or more, we use the t-distribution instead of normal distribution. The shape is similar to the bell curve, but the tails are thicker, especially with the smaller samples. That's because we are working with more uncertainty. The t-distribution is symmetric and centers at 0. Has thicker tail than the normal curve, changes shape depending on the sample size. As the degrees of freedom is increased, the t-distribution gets close to the normal distribution. Once we reach about 30 degrees of the freedom, there is neatly identical. Now we are going to find the critical value for the 95% confidence when the sample size is 15. First, type the degrees of freedom. How we can calculate degrees of freedom is 9 minus 1. So that's mean here sample size is 15. 15 minus 1 is 16. I will record here degrees of freedom is 14. So, and also in order to find the critical value here, I will show you two methods. First one is you will see that it's 95% confidence here mean in area under this curve. That's mean from negative TC to positive TC value. It's from here to here. Area is 0.95. Then it's both total probability of these two regions is 1 minus 0.95. That's mean if you get here, it's type the equal sign 1 minus 0.95. So 0.05. That's mean both regions, total regions of is 0.05. Total probabilities, two regions. Then we can record directly to the Excel directly using the built-in function. Let's type equal, then type the t distribution. Then you will see the pop-up more t distribution. We have a t inverse 2t. In here, we are going to find the inverse of t value corresponding to 2. Both side, giving the both side total, this both side probabilities. Then, so I will click here, probabilities 0.05, comma, degrees from freedom is 14. Just click it, then you will feel that, see that 2.14787. You can round off for this 4 decimal, this value, comma 4 decimal, and just enter it. So next find the other way of. So because it's 0.05 is both area, the total area of this yellow regions. So let's find only one side of area. So how we can find this value? This we can divide by 2. then 0.025. That's mean we have to find the inverse value corresponding to the probability of 0.025. This is cumulative probability of the t distribution value Tc. So then we can find using directly from Excel function, type the equal t distribution. Then you will see that t inverse. Double click it, give the probability of this, and comma, and the degrees of freedom is 14. So if we see that we got the same one, or again we can round off this value, comma, to the 4. So we get only the difference is minus, but we have to consider only when we get the critical value for the confidence bound. To calculate the confidence bound, we have to write only the without any sign, just only the value. So I will type here critical value here is 2.1448. Now we are going to construct a confidence interval. So before we find this, make sure sigma is unknown and check that either your data is normal or number of samples size is greater than or equal 30. So if you check this information given to you, so from this example, it's 16 coffee shops. I will type here 16, n is 16, number of sample, and measure the temperature of the coffee sold at each. The sample mean, that's mean is 162. This should be not like here. Let me type here. And then with the sample standard deviation, that means we are getting the sample, not the population standard deviation. Definitely, sigma is unknown. That means S is 10. Then we have to check that its data is normal distributed or the sample size is greater than or equal 30. But if you go to the last sentence, if you read it, assume the temperature approximately normally distributed. That means this data is normally distributed. So then first condition is true. Then we have to find also sigma is unknown. Then we have n value, mean value, standard deviation, sample standard deviation, and the confidence is 95. And also we have to find the degrees of freedom. Degrees of freedom is n minus 1. Here n is 16. So 16 minus 1 is 15. I will type here directly. So it is simple calculations we can do by head. And then we are going to find the confidence bounds, left bounds and right bounds. In order to find the confidence of these bounds, first we have to find the marginal error. I will type here marginal error. That's mean E. Now we are going to find the marginal error. In order to do that, I will type here on reference cell this formula equal critical value we found previously 2.145 times standard deviation of a sample 10 and divide by square root of n. That means square root function, double click it. My n is 16 and cross the bracket. Then we found the marginal error is 5.3625. In order to find the left bound of a confidence interval, left bound, then we can find from here equal its first mean here is 162 minus, this is my marginal error, this enter it. Again, to find the right bound, equal mean plus E mean my marginal error, enter it. Then we found this two. So in order to find, if you want to get your margins, bounds, it's 2 decimal, we can round up, round function, this value minus comma 2, and also here 2 equal round this value comma 2. Then we found the left bound and right bound. That's mean our confidence interval here is, you can type here with 0.64 comma 167.36. This is our confidence bound for the mean of the sample. That is for section 6.2, constructing a confidence interval for sample mean. When you don't know the sigma, the t-distribution is your best friend. So you can apply these steps with real data. Keep practicing. This gets easier with time. Thank you.